All right, good morning, wonderful people. All right, so today we are going to use linear equations to write a point on the graph and the slope, or sorry, write linear equations given a point on the graph and the slope. Also, we're going to write linear equations given 2 points and use linear equations to solve application problems. So those are the 3 main things we're going to cover today. The first thing is all right, so if we know some things about a line, like for instance, we know at least 1 point on the line, and we know the slope, well, we have enough to construct a formula, an equation for it. So it looks a lot like the y equals mx plus b. And in fact, it kind of is the same thing, but we put in some extra, an extra y and an extra x to account for that extra point. And we call it the point slope formula. And the point slope formula is pretty easy to remember because you just need 2 things, a point and the slope. If you have those 2 things, you have everything you need for the point slope formula. So let's go ahead and practice using the point slope formula. Now this is pretty easy. There's only 2 examples for it. But every ordered pair, in this case here, this point is an ordered pair. It has an x and a y value, and those x and y values, you just sort of drop them right in here. So for y, you would plug it into here. For x, you would plug it into here. So let's go ahead and try that out. Y minus 7. So again, I'm going to have to go to the y value for my ordered pair, and that would be 7 equals m, which it gives us the slope that says the m is -4, so I'm going to drop that in for the slope. X, now the first x and the first y on both of them stay x and y, they don't really change. And in this case here I have x equals, well, it's supposed to be -1. But if I drop it in here, now, for some of these, I'm going to take a shortcut. I ended up having to do that because I'm running out of space. But I end up with a double negative because I end up with the negative that comes from the formula. The formula brings its own negative. And this -1 brought its own negative with it as well. So I ended up with 2 of them. So in some of these, if I'm a little bit pressed for space, I'm going to end up having to just make that into a plus. So I kind of hope you guys know where I'm getting that from, to turn into a plus. But if I can, I'll write the whole thing out. So first things first, I am going to also get rid of my parentheses. So -4 times x will be -4x. -4 times, now this is going to be +1, which is a strange case in that we have a triple negative. So I have 3 negatives. So these 2 cancel each other out, so it becomes +1, but -4 times +1 is going to be -4. So it ends up coming right back to being negative. Now I'm going to add 7 to both sides, so +7 and +7. Now if I add 7 to -7, that cancels it out. And I'm going to add 7 over here, so now I have -4 plus 7, and I should have enough of everything to put it together. Now, if your writing is a little bit better, you could probably put the +7 down here and the +7 down here. But sometimes when I'm pressed for space, I'll kind of do this. In fact, actually, I remember learning algebra when I was like in 6th grade, I believe. And this was the method I was taught. They called it the crossing the bridge method, which I almost never see it anymore. I always see the stacked method. But basically the idea is you just move something over to the other side, but it becomes the opposite sign. So if it's negative, when it crosses the equal sign, it becomes positive. Now, I don't know why they stopped that. Maybe it was too confusing, but that's basically what's happening. But again, you can write it the other way around too. So now I have this linear function that passes through the point -1, 7, and has a slope of -4. And maybe if I had some time, I could easily plug it in. Yeah, like I said, it's not something that a lot of people teach anymore. I have no clue why. Now again, in this case here, I have my X and my Y value. Now I'm gonna skip the step where I have the double negatives. So if there's a negative here, I'm just gonna put it in the formula, but I'm gonna flip the sign to a positive. And now I'm gonna go ahead and put my slope in there, which is 2/3, and my X value. Oh, the first X stays the same, but my X value in this case is negative. So I'm gonna switch it to a positive so I can save myself some space. And like here, you can see I barely had enough room to finish this one. So I kind of have to be a little space sensitive, cognizant of my space. Especially nowadays, personal space is more important than ever. All right, now I'm going to go ahead and turn this into a number. So 6 times 2 is 12. 12 divided by 3 is 4, and that helps me do this. Now again, basically all I'm doing is minusing 5 here and minusing 5 here. There we go, yeah, it's 4. You got it. Oopsie. But here, minus 5 minus 5. But instead of doing it like that, I know that this side's going to cancel, and I'm just going to minus 5 over here. And then again, that I only do that now to save space. It's still the same thing. We're still minusing 5 from both sides. But if I'm able to write it all on one line, I don't have to, spend a whole nother line writing the whole thing. Y equals 2/3 X minus 1. There we go. Now, yeah, I don't know if I can do this, but I think we have a little bit of time today to actually kind of move around. So what I'm going to do is I'm going to go over to Desmos, and I'm going to type in that graph, and I'm going to show you that it does match up. So the one from the page, the graph we got was y equals 2/3 x minus 1. Now it has a slope of up 2/3, and we have to check it to make sure it goes through the point -6 and -5, which our graph here does do that. We have a line that goes through -6, 5 and has a slope that is up 2/3. So you can also use Desmos to check your work as well. And if we did that same thing to the other graph, it would also work out as well. This, if I typed in y equals -4x plus 3, it will go through this point, assuming we did the work right. And that was it. Okay, so again, this is Algebra 1 stuff. So you've covered it before. This is really more of a refresher. But that was kind of the easier part. This is going to be the next part, which is a little bit tougher, and that is writing the linear equations when you're only given 2 points. So having the slope really helps out a lot, because once we have the slope, we can put it into our point slope formula. Now, when you're given 2 points, you're going to have like what I call group 1 and group 2, right? Because there's an ordered pair, so it's like 2 numbers. Use the slope formula followed by the point slope formula. So use this here, right? y2 minus y1 over x2 minus x1. So you're basically plugging these numbers. So x1 goes here, y1 goes here, x2 is here, and y2 is there. So they each have their own place on that formula. Once you have your slope, you're going to plug it into the point slope formula, and then pick one of your points. In this case, it looks like they picked group 1, and they just plugged that in, and that should be able to give you your formula, just like this one here. Okay, so this is what I did right before, because in my first hour, I had to write really small to make it fit. So I made them a little bit bigger to give myself more space to write them at. So let's see if I can go ahead and put these in there. So x2, and I'm going to go ahead and make these group 1 and group 2. I'm just going to keep it simple like that. I don't think there's any real like easier way to do this. So I'm going to go ahead and put my y2 here. So you're probably going to need your formula for this one if you don't remember it. So y2 minus y1. So there's my group 1, there's the y. Now I'm going to need to do the same thing with the x. So group 2's x, so -3 minus -6. And let's go ahead and calculate out our slope. So 7 minus 1 is 6, and -3, now again, this is a double negative, so it's going to be plus. -3 plus 6 is 3, which if you can divide it, divide it. If you can't, then simplify it. So in this case, I got 2. So my slope is 2. Now I'm going to plug this into my y formula. So y, and I'm going to just use 0.1 here. If you do a little bit of thinking, sometimes you can make this easier on yourself and pick numbers that are easier to calculate. But in this case here, I'm just going to go with group 1. I could easily use this group and I would still get the same answer. Because remember, we're looking for the same line in both cases. Now in this case here, I end up with, again, minus -6. But rather than put 2 negatives, I'm going to just put it as plus. Y, and oh gosh, I still got to get rid of this thing here. I wanted to get rid of that 1, but I'm going to have to get rid of the parentheses first. 2x plus 12. Now I can minus 1 from both, well, not really minus 1. I need to get rid of the -1 by adding 1 to both sides. So now I should have my final answer. Y equals 2x plus 13. And that looks about right. So let's go ahead and box that, and that's our answer. All right, so same thing with this one here. We're going to have to calculate our slope first. So, okay, maybe after this one, I probably won't be using the x and the y so much because now you'd probably know which ones are which, right? Because x and then y. But I do that because a lot of times students end up doing something, you know, like this, where they put the x over the y when it should be the y over the x. So maybe it helps. If it helps, go ahead and put it on there. Now again, it's supposed to be minus -2, but we end up with a double negative, so that's going to turn into a positive. And here I have -x plus 2. There we go. And again, it would look like this, but I'm going to just sort of skip that step. I don't like doing it, but sometimes I have to. And in this case, I get -4. It's -6 plus 2 is -4. And I can divide this. I would get like 2.5 or 2.5. But don't forget, when you're working with slopes, it's oftentimes better to have a fraction. It's better to have a fraction. So rather than go with 2.5, I am going to go ahead and reduce my fraction. So I divide this by 2, divide that by 2, and I'm going to move the negative to the top number too. That's another thing you can do with these kind of numbers, is take your negative and move it to the top number, which is kind of the way I prefer it to be written. Because one small problem that I usually have with that is I'll get students who will put their negatives right there. And you can see that there's a problem with it being seen because it's easy to forget it. You might forget it, and the person checking your work, you know, your teacher, is probably going to miss that part too, where he's going to say there should be a negative. So just to kind of get around that, I always put my negatives on the top number. Anyway, let's go ahead and move on. So I'm going to put my formula together. So I'm going to go ahead and, again, put in -2, which I already have a negative in there. So next I need to put in my slope, x. And again, this is also going to be a +2 as well. Let's go ahead and get rid of these parentheses. Y +2 equals -5/2x. And that's going to be a negative, so negative times a positive. And it's going to be 10/2 because if I turn this into a fraction, so 5 times 2 is 10. Bottom number is 2 times 1, which is 2. So 10/2. And I can divide that. 10 divided by 2 is 5, which makes it a little bit easier to move that out. Now, again, I could easily go like this, all right, just -2 from both sides. But when I do that, I already know that this is going to cancel, and I just -2 from here like that. And again, that saves me a whole bunch of space in writing this problem out. And again, it's an older method, but it still works, still checks out. And maybe change that top number a little bit, clean it up a bit. There you go. Now we have our line. And if we were to graph that onto Desmos, we should be able to get the line to go through the point -2, -2, and -6, 8. And that's how you find the point slope when you only have 2 points. All right, so we have 2 more problems with 2 more points, and then we're going to go into some word problems. Ooh, gosh. Ugh, what a lazy Thursday today. All right, so let's go ahead and do this one. So again, I'm going to leave out the part where I put the x and the y on there. So y2 minus y1, so group 1y. Now in this case, maybe I can just keep putting them on there like this. 1 minus 10. Now -8 plus 5, because again, 2 negatives would make it positive, so that'd be a +5. That would be -3 over -9. Since they're both negative, I can go ahead and cancel the negative, so it'll make it positive. And if you remember when on Monday when I was talking about the slope, I was saying that if you have a negative on top and a negative on bottom, like when you're trying to graph, but then your line goes off the paper, off the graph, you can go backwards and it'll still work out. Same idea. 1/3, so I'm going to reduce my fractions. Now I need to plug it into my point slope formula. And I'm going to pick one of them. Now I'm going to pick this one. I'm going to do something a little bit different, and I'm going to pick this one because it has smaller numbers. And it's not always easier just because the numbers are smaller, but usually it is. But it's really what numbers you would prefer to work with. Now, I think I put it in the wrong place, so be careful with that. Now, that's actually something that happens a lot with students. Make sure you put this in the right place. So again, make sure that you don't mix them up. This is X, and that's Y. All right, again, that's a pretty common thing that happens. All right, so let's go ahead and multiply to get that parenthesis out of there. So 1/3 x minus 1/3. Ooh, okay. Now it looks like I'm gonna have to -8 from both sides. So -8 minus 8. And since they're both minus, I think that that would make them easier to work with. Now, when you're adding a mixed number to a whole number, that is a tough thing to do. But in this case here, it's like saying if I had like say $8 and I add 33 cents, just put them together. Y equals 1/3 x minus 8 1/3. And it looks like we're done with that one. All right, let's go ahead and move on to this one here. So it looks like we have a bunch of negatives in this case here. So we have group 2, group 1. So -3 plus, okay, so there's the y for this one. So again, it's going to be a negative number, so minus negative, which is going to make it positive. Here I have my x value. And again, negative and negative is going to change it to a... Oh, man. Sorry, I've been having like really weird itchy nose and eyes all day. I don't know, maybe there's a cat or something that moved into the neighborhood. All right, so 8 minus 2, that would be, well, it wouldn't matter what the bottom number is. The slope is 0. 0 divided by any number is going to be 0. So that might actually make the slope easy to calculate, because let's go ahead and plug in a point. Now I'm going to plug in 0.2 again, just because it has the smaller numbers. And if I were to plug in this side, I would still get the right answer. I'd still get the same answer. The answer would be exactly the same. So plug in 3, and here I'm going to plug in 2. And again, make sure you put them in the right spot, because it's easy to mix them up. And multiply it out. Y plus 3, and 0 times x is going to be 0. And 0 times 2 is going to be 0. Minus 3 from both sides, minus 3 here, minus 3 there. Y equals -3. And that's it. Right? Nothing else we can do with that one. So that's it. You got them with 2 points. All right, using linear equations on applications. So how we would use them in a way to apply things that might apply to everyday life. Now for this one here, it says a cab ride is $4 plus $1.75 per mile driven. Now I've only ridden a cab once in my life. And that was in Flag, and I don't remember why or where or something like that, but I was going to a buddy's house or something, and there was no way to get there, and for whatever reason, we didn't have a ride. And it's like, again, the only time I ever remember calling a cab, and this is like 15 years ago, so a cab was the only thing. There was no Uber or anything like that. Uber's only been around for like, I don't know, 5 years maybe or something like that. But this price seems kind of high, but we'll just run with it. Write an equation to represent the cab fare for $4 and $1.75 per mile. Define the variables. So I'm gonna, now what I should do is I should put this into y equals mx plus b. But in this case here, we're not graphing it, so we don't need to really put them in that order. So let's just leave it the same as it kind of is, 4 plus 1.75, and we're done, right? Now, again, this cab fare changes depending on how far you are driving. So if you're just going down the road, you know, won't be that much. But if you're going to be driving a long way, it's going to cost more, right? The longer they drive you, the more it's going to cost. And that makes sense because you're using up the cab driver's time and gas to get there. So we are going to use M for miles. M equals miles. And I could put C for cost. C is the cost of driving the car, or sorry, riding in the car. And that's it. There we go. It just says to write the equation for the cab fare and define the variables, which we did. Now, if Clay, his destination is 17 miles away, he has only $30. Will he make it? Now, this is a tough part here because sometimes when people miscalculate these things, you know, paying the cab driver is tough. Now, back then, like even using a credit card was kind of a tough thing to do. You know, not everybody took it. And I remember back when there was a Toys R Us store, they still had those, they call them knuckle busters, I think is what they're called. It's like a big machine and there's like, you run a stamper over the credit card and it makes like a bank slip. And it basically just copies your credit card's number and then they run it later at the bank. Man, how things have changed now. I think with Uber, you use an account and like you put money in that account and then you drive places. So there's no chance of you not having enough money. So in this case here, he's going 17 miles. And since M is the miles, I'm going to go ahead and replace M with 17. I'm going to go ahead and use the calculator on this one. 7 times, I'm sorry, not 7. So 17 times 1.75. Keep pushing the wrong button. Now, if we're just counting the miles, 17 miles at $1.75, that's going to be $29.75 plus 4. And it says here he has $30. Now, actually, in this case here, we don't really need to, but I'm going to just go ahead and plug it in anyway. It's going to look like that. No. Be the other way. But, you know, let's just leave it out. We're not working with inequalities, and we're just going to have to make a final decision with this one here. So that would be $33.75 is his cost. The cost is $33.75. And the question is not how much is it going to cost, because if the question was how much is it going to cost, then we would have our answer right here, $33.75. But the real question is, will he make it? In this case here, the answer is no. Now, I don't know, maybe the cab driver will be chill about it and say, you know, don't worry about the $3, I'll, you know, whatever. And again, that's almost what happened with us. We almost didn't have enough when I took the cab. Like, I think I had like barely enough change to cover it. Like, I was completely broke when I got through there. And again, that was a long time ago. I don't know if there's even cabs anymore with all the Uber and stuff going on. You know, I should ride an Uber just for fun, just to see what it's like. I mean, I know it's just like people themselves using their own cars to drive people around. All right, I'm going to move this a little bit higher. All right, so here we have people, the Jones, purchasing a new home. The closing costs are $249 plus 3% of the purchase price of the home. So closing, like when they say close a deal, that means at the end of it. So closing price is when all is said and done, basically, like when the contract and everything is covered. So again, that's just like the final thing, the final deal. So write an equation to represent the closing cost and define your variables. So closing cost, the we still have the y equals mx plus b, so there's a beginning. So this number begins at $249 plus, and again, I'm just going to keep it in order so that way it just makes it easier to read. 0.03, and that's how you say 3%. So to turn a number into a percent, you times it by 1/100th and then put the percent on it. But actually, that's kind of a whole lesson on its own. That actually can be a whole lesson on its own. But anyway, there you go. That's how you say 3% as a decimal. And here it's we'll go ahead and use cost and purchase price. So we'll put P for purchase price. And there we go. So C is cost and P is purchase price. Purchase price of their home is $195,000. Ooh, expensive. But I guess in most places in America, that's about kind of an average cost of a home, actually. So the seller offers $5,000 in closing costs. So that's how much they have. That they have $5,000 in their pocket. So it's kind of like the CAB question. Are they going to have enough to cover with their closing costs that they have? If not, how much will they need to pay out of pocket? So let's go ahead and use our function here. So we know that the purchase price, so $249 doesn't change, but the purchase price is 3%. 3% of $195,000. Now, if you're in the bank and you're trying to get a loan for a car or a house, that percentage rate, the what do they call it? Oh, yeah, in this case, they just call it the percentage rate, but it's actually called the APR is what they call it. And that is a percentage of how much you pay. So 3% doesn't seem like a whole lot, but take 3% and times it by 195,000 and you get 5,850. So that means they have to pay $5,000 extra, or almost $6,000 extra. But in reality, that's not bad. In reality, it would be closer to like 10%. And that's just something you kind of learn through the whole thing. So they have to pay $6,099 before they even close the deal. So in this case here, the guy says, well, I'll go ahead and take off 5,000 of that. So in this case here, the answer is no, they don't have enough. And they're going to have to pay about, let's see, about $1,099. Now this is kind of a tough question because I actually had to read it a couple times. Well, actually in my first hour writing it, I think that I had to kind of really think about it. Because it does say that there is $5,000 that they're going to go ahead and just sort of get off. So like in assistance, that's how much like someone might give to them for that. So like a discount. All right, so here we go, another one. A 22.5 ounce candle burns at a rate of 1 ounce every 5 hours. So that makes sense. If you light a candle, it's going to start burning, and as it burns, it's going to get shorter and shorter. So in this case here, we have a candle that burns at a known rate. So write the equation of how much candle is left. Define your variables. So we start with 22.5 minus, and this is the hard part here because you might say 5x, but that would mean every hour it burns 5 ounces, which is not true. It burns 1 every 5 hours. So this one here is again, a bit of a tricky one. 1 every 5 hours. So you have to think of it in terms of, okay, well, what would X have to be in order to burn 1 ounce of candle off? In this case, if it was 5 hours, that would burn 1 ounce of candle off. So how much is it for 1 hour? That's 1 divided by 5, or 1/5. Again, that's kind of a tough one. I don't think very many people would get that on their own. And here I made a mistake. I'm going to go ahead and redefine my variables. Instead of X, I'm going to put on H for hours. And I'm going to put here, I'm going to put O for ounces, but then that looks like 0. So what else could I use to do this? Maybe we'll do C for candle. So C is candle weight, and H is the number of hours that we are using, that this candle has been used. So again, the more this candle is lit, the longer it goes on, the shorter the candle itself gets. So that's a negative relation. So again, negative going down. How many hours will this candle last? So with this one here, C is 0. So we're looking at the time. The time is what we don't know, time in hours. So H is going to stay, and this is why I didn't want to use O, because it looks like 0. So we're going to have to solve it when C equals 0, when there is no candle left. So I'm going to add 1/5 to both sides. There you go, 1/5 to both sides. And let's just add 1/5 here, add 1/5 here, so now it's on this side. Now, since I have H divided by 5, I need to get rid of that by timesing it by 5. So times it by 5 here, times it by 5 here, and H equals, let me grab my calculator for this one, 22.5 times 5, and that's going to be 112.5. And that's pretty good. Somehow that doesn't seem right, because that would mean that this candle can burn for 4 days straight. And I don't know if that's actually possible. But then a 22-ounce candle is a pretty big candle, though. I mean, that's like a medium-sized drink from a fast food restaurant. So that's a pretty big candle. So maybe it can burn for that long. One kind of interesting fact about candles that I never knew. So I always used to pour the wax off of the candle when it burned, thinking that, you know, the candle flame is gonna go under the wax and go out, like drown the flame. But I actually found out the other day, like maybe not the other day, but within the last month, I actually found out that you are not supposed to pour the wax out, because the wax is actually what's burning, not the wick. Who knew? I never knew that, because it like the wax that the candle is made out of melts, and then it vaporizes, so it's drawn into the flame, and that's actually what does the burning. Interesting. So I guess candles just last longer if you just leave them alone. All right, here we go. So next problem here. So it says to use standard form. So if you have your packet with you, there is a big thing up there that says using standard form. So that's a big clue to what formula we're going to be using. So this guy Josh bought 3 bags of potting soil and 10 bags of mulch from Home Depot. Write an equation to represent the total cost and define your variables. So using standard form, remember that's the one that goes like AX plus BY equals C. So in this case here, we'll have A or X equal soil and Y equals mulch. So all we need to do is just plug these in. 3 times soil, so he bought 3 soil, plus 10 bags of mulch, so Y is mulch, so the number of mulch bags, equals C, which will be our total cost. All right, so we're gonna have to kind of work backwards with this next one. Kind of similar to what we were talking about when we were talking about functions. Can you determine how many of something somebody has bought if you know the total and how much that item was? So in this case here, it says that Josh spent $40.91. So that is the cost, $40.91. And it says here mulch is $2.75 per bag, so 10 times $2.75 plus the potting soil. So the potting soil, well, we don't know what the price was, so it's going to be 3 times X, because again, we don't know how much the potting soil costed. Wait, is costed a word? Has cost? Is cost? Has cost? Has costed? Anyway, so let's go ahead and get that X by itself, because once we get that X by itself, we will know how much it was. Now, timesing something by 10 is super easy, especially if it's a decimal. You just move that decimal one place higher, so just move it. So it becomes 2.75, move it over, it becomes 27.5. Now I'm gonna go ahead and minus 27.5 on both sides, 27.5. And again, I'm doing this just to save space. I know it's different than the way most people are used to doing things, but it's just done to save space. There you go. So I got 1341, 3x, oopsie. 3x equals 1341. Now I'm also gonna have to divide both sides by 3. So divide by 3, and you can already see that I'm running out of space. Divide that by 3 and we get X, the cost of a bag of soil is $4.47. Now I never really bought soil, but that makes sense to me. And there we go. All right, next problem. Kaylee has a collection of quarters and nickels. Write an equation to determine the total value of the coins and define your variables. So I'm going to use the same formula, AX plus BY equals C. And I'm going to go in the order that they were mentioned. So the first thing they mentioned was quarters. So I'm going to put 0.25 because that's how much it's worth. And X is the number of quarters. And that would make Y the number of nickels. Plus, and then for nickels, that would be 0.05 Y equals, we'll just leave it as C for total cost, even though we're not buying anything. All right, so here we go. We have the total value of coins is $5.50. Kaylee has 17 quarters, so how many nickels would she have? Okay, so we know how many quarters there are, so 0.275 times 17. So there are 17 quarters, which that's about, like so 16 quarters is $4. So that's about $4.25 worth of quarters. Oops, sorry, jumped ahead. 0.05y, we don't know how many nickels she has, so that makes sense that we leave it as y, but we do know the total of the total value of the coins. Now that says equal. I don't know why I put equal there. That should be a plus sign. Plus 0.05y equals 550. Now in this case here, I'm going to go ahead and minus 425 from both sides. Minus 4.25. And I think that's $1.25. But let me just, I don't want to make any mistakes here. So $5.50 minus 4.25, and that is $1.25. So the value in nickels is $1.25. So if I said you have $1.25 in nickels, you could probably tell how many nickels that would be. But that would be about 25 nickels. There we go. Okay. And that's it for that one. So again, we're using standard form. Now I think in this one, in this next one, there's a repeat of the problem. I think it was this last slide here. So we've already done this top one. It's the exact same problem. I just did not. Come to think of it, why did I do that? It would have made more sense to just, never mind. All right, so concession stand. The baseball concession stand sells soft pretzels for $4.50 and bags of popcorn for $3.25. Now that sounds good. I wish I could have a pretzel right now. Man, if only the theater was open, I could run down there right now during lunch and grab one. Actually, no, they only open like after 3 or something. But I could grab one on my way home though. Anyway, I missed the theater, I guess. Write an equation to represent the total sales of pretzels and popcorn on a given day. So define your variables. So we're still using standard form. So again, I'm just going to go in order. So X will be the number of pretzels. So it's $4.50 for a pretzel and $3.25 for a bag of popcorn, which I'll just call Y. So X equals popcorn and Y equals, oh wait, no. What am I talking about? I'm losing focus here. I decided to keep it in order. It's always best to just keep it in order. Pretzels, how do you spell it? And this one is, close enough. And that will be the C, which will be the total sales of the day. C is total. Now we get into some of the things we know and some of the things we don't know. So it says they sold 137 soft pretzels. So we can start putting that into our our formula. How many bags of popcorn would they need to sell in order to make at least $1,000? So plus, we don't know how much popcorn. So in this case, we're trying to predict. We're trying to think forward about how much popcorn would we have to sell in order to make $1,000. Now in this case here, at least $1,000 would be an inequality. Really, in reality, it would be an inequality, not that, because we can go over it. But I guess in this case, we're just going to kind of work the problem out and use our mind, because we know if we sell more popcorn, we get more money. But right now, we're looking for the lowest amount of popcorn that we can sell to break $1,000 if we are almost certain that we can sell 137 pretzels. So let's go ahead now. I'm going to use my calculator again. 137 times 4.5. And that would be $616.50 worth of pretzels. Wow, those pretzels really do add up. Now, one thing about being a math teacher, sometimes I overthink things. The reason why movie theaters and concession stands sell popcorn is because it's cheap. You can buy a huge dog food sized bag of popcorn that will literally make like a whole room full of popcorn, and it only costed you like, I don't know, I think if I remember correctly, this is like 15 years ago prices. It's like $20 for a big bag of popcorn, but you're gonna make like buckets and buckets and buckets of it. So really, that a regular sized popcorn at like those little paper bags you get at the concession stand, yeah, those only costed them like, 25 to 50 cents, maybe even less to make. And pretzels, however, have a much lower profit margin. I don't know, I'm overthinking about it, sorry. Kind of like soda drinks. Everywhere in America, you can buy a soda drink, and that's because the soda machines, once you buy the machine, the soda becomes much cheaper once you have it. So if you're buying canned sodas, yeah, it's going to be a lot of money because you're buying the can with it too. But when you buy a paper cup with it, then it's really not that bad in price. And that's why you can buy a big mega gulp at the Chevron for $1, something like $1.25 for a big 32 ounce. Because you're not buying the soda. In that case, the cup is probably more valuable than the soda. And that's why most restaurants allow you to get free refills. All right, so if I keep going and solve it, y would have to be equal to 118. So we'd have to sell about 118 popcorn bags in order to break $1,000. Okay, and that's it for this one. Let's go ahead and go on to the next thing. Now for these ones, I might just touch a little bit on them. I won't spend too long on them, but we're going to talk a little bit about scatter plots. So with scatter plots, I'm trying to think of a really good example because during my first hour, I did not have a very good example. Let's say it's height to age, all right? So if you were, now being in school most of your life, you've always been near people who are your age, right? Every grade, you're always with people that are your own age. So you've also noticed that not everybody is the same height, but everybody in most grades are going to be taller. So if you were to go to third grade and then measure the height and then go to fourth grade, chances are good that most people will be taller. All right, but it's one of those things that some people go growth spurts and will be like, oh my goodness, what happened to you? Other people will be shorter. And I guess sadly, some people stay a certain height for a long time. So height kind of varies, but it has a positive correlation. The older somebody is up to a certain age, so usually people stop growing around 20 or so. So right around 20, people stop growing. So let's just say that this is ages 1 through 20. That's a positive correlation. People in general get taller the older they are. And again, there are some outliers. You might get some people that are short and stuff. But for most people, you can see that there's a positive relation that goes upwards. And here we have a negative correlation. So a negative correlation would look something like this. So a negative correlation would be something like, I'm trying to think of something else that varies again, something that changes a little bit each time. But it's something that it goes down a little bit more than, gosh, what goes down? Maybe we could use that candle example, okay? So candles, again, are a little bit different. The longer they burn, the shorter they get. But sometimes things happen, like wax spillages that cause a candle to last a shorter amount of time, or maybe they keep going out and you have to keep relighting them. So there are little changes that they're not going to last perfectly the same amount of time each time, but it will go down in general. And then there is no correlation. Now this is one of those things that if you watch the news all the time, they use the word correlation a lot. They will say, this thing causes crime, and that's what the numbers correlate. They will say things like, you know, the president's policy correlates to the SARS-CoV cases or something like that. Now, in some cases, there is no correlation. Now, that doesn't mean there's no relation. It just means that there's no data that we can see that makes sense from what we're looking at. So yeah, there you go. Correlation. In this case, it doesn't make sense. It doesn't look like it's going up. It doesn't look like it's going down. It doesn't even look like it's going straight sideways. So the points are just all over the place. And what you can do is draw a line of best fit. You can see that you can draw a line through these first two. If you had to draw a line through this, it'd be a lot harder because you just couldn't do it. And that's what you call a line of best fit. So let's go ahead and I'm going to just graph these. So 90, and I'm going to go down 5 and go to 80. So each of these is going to be about 2. And I don't need to go much lower than 70. 5, 10, and 15. Wait, hold on. 15 is going to be about right there. Oh, did I think I did not go far enough for that. Oops. And let's just try our best to write out these. So here it shows the relationship between the depth in a lake and the water temperature. And again, if you think about it, it makes sense because the top part of the water is going to be the warmest because as you go deeper, the light, there's just not as much light getting down to the lower parts of the water. Now again, water is not just entirely dependent on light for the temperature. It actually, it relies on a lot of other things like the water currents, you know, which way it's heading and all that stuff. Now in this case here, as you can see, we go down further and further, we get colder and colder temperatures because there's just not as much light getting there. And again, this also depends on a lot of other things, including time of the day. So it's not going to be a perfectly straight line every single time. It's not going to be 100% predictable. So it says here to use 2 ordered pairs to find a line of best fit. So I'm going to use this one and this one just because of 0 and 10 is a pretty good way to measure it. And I'm going to kind of, again, relabel these as X and Y because the input is how deep it is. So maybe we're putting a thermometer on the end of a string and we measure out 10 feet and we get the temperature, right? Something like that. But anyway, the input is the depth. So the output would be 85. So 85 85 minus 79, because I need the y here, and then now I go here, so that would be x2 minus 10. There you go. So we would have 6 and negative 10. And I'm going to go ahead and put the negative on the top number and reduce it. So I got negative 3/5. Now I'm going to plug it into one of my points. I'm going to plug it into my top point using the exact same thing I had earlier. So plug in my y value, which is 85, which I need minus 85. I'm getting ahead of myself here. Negative 3/5 times x minus 0. And I'm going to go ahead and distribute y minus 85 equals negative 3/5 x. And anything times 0 is going to be 0, so that's why there's nothing here. And I'm going to add 85 to both sides, which actually completes my equation. I now have all the parts of the equation. I'm going to move this up just so I can write a little bit more under what I have. So that's going to be y equals negative 3/5 x plus 85. And that's my line of best fit. All right, it's going to go through most of the data points, through the middle of most of those data points. And we can use this to predict it. So here, last question is predict the temperature of the lake at 25 feet. So maybe we don't have a 25-foot string, but we want to kind of guess how the temperature will be 25 feet down. So what we can do is plug in 25, because x and d for depth are the same thing. And this will give us a really good idea of what we got. Okay, we're almost done. Just give me one more minute. All right, 25 times negative 3 is negative 75 divided by 5 would be negative 15 plus 85, which means the temperature would be about 60 degrees. I hope I did that right. Actually, no, wait, no. That wouldn't be 60, it would be 70. Anyway, yeah, we're a little bit over time. We'll go ahead and stop here for today. I'll tell you some more things going on in just a minute. That is it for today. There will be the usual time for questions if you need to. If there's nothing else, then I will let you guys go. Bye.